Anyone who has ever squirmed through a dental cleaning knows how sensitive teeth can be. This sensitivity provides important feedback about temperature, pressure, and pain as we bite and chew. However, the sensitive tissues inside hard enamel originally evolved for a very different purpose. New research from the University of Chicago shows that dentine, the inner layer of teeth that transmits sensory information to the nerves in the pulp, first evolved as sensory tissue in the armored exoskeletons of ancient fish. Paleontologists have long believed that teeth evolved from the bumpy structures found on this armor, but the purpose of those structures remained unclear. A new study, published in Nature, confirms that these features in an early vertebrate fish from the Ordovician period, about 465 million years ago, contained dentine and likely helped the animal detect conditions in the surrounding water. Research also revealed that structures previously identified as teeth in fossils from the Cambrian period, 485 to 540 million years ago, closely resembled features in the armor of fossil invertebrates, as well as the sensory organs found in the shells of modern arthropods such as crabs and shrimp. These similarities suggest that sensory organs in the armor of both vertebrates and invertebrates evolved independently to help animals perceive their environment. When you think about an early animal like this, swimming around with armor on it, it needs to sense the world. This was a pretty intense predatory environment, and being able to sense the properties of the water around them would have been very important. So, here we see that invertebrates with armor like horseshoe crabs need to sense the world too. It just so happens they hit on the same solution. Researchers contacted museums across the country, requesting fossil specimens from the Cambrian period, 485 to 540 million years ago, so she could CT scan them in search of signs that indicated vertebrate features. One of those signs, at least in later fish, is the presence of dentine inside. The bumps on external armor, called odontodes, they collected hundreds of specimens, some just tiny fragments that could fit on the end of a toothpick. They then took them to Argonne National Laboratory for an all-night scanning session using the advanced photon source, which captured extremely high-resolution CT images of the fossils. It was a night at the particle accelerator, as they started seeing the images from the scans. One of the samples from a Cambrian fossil called Anatolepis looked like it showed the hallmarks of a vertebrate fish. It had a series of tubules, or pores underneath the odontodes, filled with material that bore the chemical signatures of dentine. If it truly was a vertebrate, the specimen would have extended the fossil record back by tens of millions of years. Once they compared the possible vertebrate Anatolepis to a known arthropod fossil from the Milwaukee Public Museum, they realized that what looked like dentin-lined tubules of a vertebrate were more like the sensory organs on the shells of crabs. It's called sensilla. This means that Anatolepis, which was claimed to be a vertebrate in the pages of Nature in 1996, is an ancient invertebrate arthropod instead. The large tubules in another Ordovician vertebrate called Argonne were similar in structure to these sensilla, but did contain dentine.